control. This is the simple delta, the foam delta that I flew in the last two videos that I posted. Quite a few people are interested in various aspects of this. And if you're trying to build something, a flying wing with a flight controller of some sort, or a fixed wing aircraft, this is probably a good place to start. These things are very cheap to build, very light, and quite hard to damage. And if you do damage them, they're cheap to repair. This is where I flew it into a tree here. This little red line is just some hot glue where I've just glued another section in. That was 10-minute repair, costs pennies. If you'd have crashed a proper kit into a tree like that, you know, you might be out of action for days, or damaged it beyond repair. So it's worth considering this this method of construction if you're just going to be learning and likely to crash. Couple of other little things here. This is a 3D printed part here. It's super handy having a 3D printer when you're doing stuff like that. You can see the this engine mount here was designed in a couple of hours, and actually I got someone to design that for me who's really good at that stuff. But I could have designed something that would have worked. Wouldn't have looked as pretty as that, but it would have worked. Here also, this is a 3D printed bracket for the camera. This is a 10-minute job, just designed with sort of software that runs in a browser called Tinkercad. That little plate there for the release hook is another 3D printed thing. These kind of things are really handy. You've got here on the back another 3D printed part. It's just to spread the load of that servo so that servo can't move. Anyway, that's 3D printer, basic idea, really useful thing. So anyway, I'll go through all these parts so you can understand what's what. There's a motor here, brushless motor. That's obviously the main drive motor. The Pixhawk is the center of the operation. This is a flight controller. This is a Radio Link Mini Pix. I think this is really good value for money for what you get with it. It's worth noting that when you get one of these things, you have to set it up for the kind of aircraft it's being used on. These things are hugely versatile, so you can use this thing on a rover, like a four-wheel vehicle, or some kind of crawling vehicle, or something like that, or a flying wing, or a quadcopter. So this is great. The problem is, because it's hugely programmable, it also makes it complex as well. So the first thing you need to do with this when you get it is set it up for the type of plane you're using, and then set a few settings for the very specific plane you're using. So that's an important thing to understand. There's quite a lot of software configuration to do that on that, just to make it work, but it's not so complex if you break it down into its components. Now, here's let's see. This little connector board here, you can see that's specific to this type of Pixhawk. It's just to allow you some extra ports. This one, we've got the GPS sensor connected to it, as well as the airspeed sensor. So that's all that does. This component here is a button, a lamp, and a buzzer. This is because the Pixhawk gives out different tones when you switch it to different flight modes. It makes an arming noise as well, so you know when it's armed or disarmed. If the thing's not armed, none of the motors or servos will work, and frequently people can't understand why things aren't working when they're testing them and they don't have the thing, have it armed. So you need this button to arm it. Here is the receiver for the radio. This is using a protocol called S-Bus, and it plugs into this port here on the Pixhawk. That basically, in those videos that you saw, that's flying in fly-by-wire mode most of the time. So the computer here, the Pixhawk, is flying the plane, and you're sending signals via the receiver here to the plane, telling you what you want it to do, but the plane won't fly outside flight envelope of the plane. So it's a very well controlled, easy way to fly a plane. As you can see from in the video, when I'm doing those hard left turns, I'm just putting the stick hard left, and it's not letting it bank more than 45 degrees. It's really cool. It actually makes it very, very easy to fly. I wish I'd known that at the start. You find that it does say this in some of the documentation, but there's so much documentation. There isn't an easy way to get started on this stuff unless you do something like this. So you've got here is the power distribution board. That's got things like the voltage and current sensor on. So it also gives you various power outputs for the Pixhawk and other components. This here is a BEC. This takes whatever voltage battery you've got here. This is a LiPo connector here. I left it off the diagram, unfortunately. There should be a LiPo battery sat about here, but it fell off in the last crash and I forgot to put it back on for this. But there's a LiPo battery that sits here, plugs into there. Anyway, this BEC here, this is really important. This is another thing that people don't realise and causes a lot of problems. For these servos to work, you have to supply the 5 volts to the Pixhawk. It doesn't supply the voltage for the servos. There's a very good electronics reason for that. Is that because if the servos get jammed or something goes wrong with them, it can disrupt the power supply to the Pixhawk itself, and if that happens, then you're in trouble. So the 5 volt rail from the Pixhawk is powered by this BEC, which is this little device here. Okay, the other thing you've got here is the telemetry radio. This is a super useful thing. Even if you're not going to fly it and use it in live flight, it's actually very handy to connect the computer to the Pixhawk when you're setting it up, because when you calibrate the compass and the gyroscopes and this kind of stuff, you have to move the aircraft in all sorts of different positions, and that's difficult to do that with a USB cable plugged into the flight controller. So actually, even if you're not going to fly this thing, for the cost involved, which isn't much, it's very handy to have a telemetry radio. That's basically what that allows you to do. It's like having a USB cable with a transceiver in the middle. So instead of it's the equivalent of having like a 500-meter long USB cable. But the problem is with it, it's very slow. But it works. It's good enough. What else is there here? Yeah. So the movie itself that I put on YouTube, it's filmed with this little tiny run cam here. That's the camera at the top, but also you've got you can't see it there, but there's a little circuit board there with you plug in an SD card, and as soon as you turn this thing on, it starts recording video. That's how those videos were made, which I thought they looked pretty cool actually. You've got the airspeed sensor here. That's important if you're flying in any kind of windy weather, because the ground speed you can get from the GPS. You've got to remember that the flight controller is taking all the sensory input it can get and making a best guess of it all the time. So the more sensors you put on it, the better. But if, for example, you're flying into wind, the flight controller can only know that if it can look at the difference between the ground speed and the airspeed. So you can have some problems if you're with your aircraft just sitting still in the sky, flying into wind. if it's not got an airspeed sensor, I've seen that happen. Now, I think that's pretty much about it. There's another point I made on here is these things with the red dot. These are non-essential things. So you don't need those to fly the aircraft. This is one way of saving a bit of money. And yellow dot items, anything just about actually I missed one off here because you can actually program the ESCs as well. It's amazing, a lot of this stuff requires software or firmware to be installed. the telemetry radios at some point they stopped working, and I had to reflash them to make them work again. So there's these kind of things that are just a bother, which can make this whole thing look very overwhelming at the start. So that's why you need to take it step by step. Anyway, that's explainer of what these things are. If you want this picture and any direct help, just contact me in the comments below. I've put my under the description. You've got my Telegram and email address, so you can contact me directly if you need help with the stuff. But this is how I would start anyway. You can see it flies. Now, the downside of this is, of course, this is a very unaerodynamic aeroplane and very, very inefficient, because you've got all this stuff stuck on the wing surface. It's not a proper wing, but it did enable me to work out how to use everything and make it all work. And now I'm going to take all this stuff and put it in a proper flying wing. Anyway, that's it for now. I hope that's useful. If you've got any questions, contact me directly. Thanks very much. Bye for now.